This video recording is going to focus on the division of algebraic expressions, but particularly this particular one will just be looking at dividing monomials by monomials, and then a poly, meaning many terms, polynomial, by a monomial. I want you to know that these first two pieces out of three, first two objectives out of three, are very, very nice, and most people enjoy them, find them pretty easy to do. The third objective, dividing one polynomial by another polynomial, a little bit harder, and I'm going to make sure I do that on a separate recording. So first of all, before we do some of these short monomial divided by monomial, number 1, or number 4, monomial divided by a monomial, one term divided by one term. I want to take something very simple and remind you, because we did this in a previous section. I want to remind you that if you have a to the fifth divided by a to the second, that if I wrote that out longhand, I'd have a times a times a times a times a. There's a to the fifth. And downstairs, I'd have a times a, because that's a to the second. Go get a different color here. And then a over a is equal to the number 1. So they reduce away, if you will, and a over a is equal to the number 1. So upstairs, what I have left is 1 times 1, which is just 1, times a times a times a. So I am just left with a to the third power. And so I want you to notice the original exponents, the 5 and the 2. If I had just taken 5 and subtract 2, I would have gotten my exponent for my final answer. So we go down here to number 12, and we think of this. We don't write it out 12 times, the letter P. We just say, well, 12 minus 9 is a value of 3. So this expression reduces to p to the third power, and that's upstairs. This next one, I want you to see that if you, when you divide, you subtract. If you subtract, take this exponent and subtract that one, a negative 2, take away 8, just 8, take away 8 is a negative 10. A lot of people want to add these two and get 6, but it's a negative 2 take away 8 is a negative 10. So you would have r to the negative 10th upstairs. But remember, we don't like to record or report our answers with negative exponents, so we write this as the reciprocal, 1 over r to the 10th power. I want you to remember, however, that this r to the negative 2 in this numerator could have been thought of as 1 over r to the second, and it would have been next to a 1 over r to the 8th, and sure enough, when multiplying these together, multiplying these denominators, I add their exponents, because when I multiply, I add, and 2 plus 8 turns out to be that 10 as well. So, you know, subtract when you divide. So if we go up to number 3, 3 minus 5 is a negative 2. So that's n to the negative 2. But can you tell that there's 2 more n's downstairs than there are up here? So we're eventually going to move this downstairs. The 6 divided by 2 is just arithmetic. 6 divided by 2 is the number 3, period. I'm not subtracting those. Those are not bases, n's raised to a power, where I subtract their exponents. Also, when I move the n to the negative 2 downstairs, I don't move the 3 downstairs. The 3 is just the number 3. So I keep it upstairs, and I move the n to the second power downstairs. You don't have to show me all this work. If you can visually see that n squared was left downstairs, that's great. Again, remember, with numerical coefficients here, I'm going to go ahead and change my color. With numerical coefficients, I'm just dividing these or reducing this fraction. So 4 goes into here 5 times, and 4 goes into here 4 times. Now, I'm going to see if you don't mind, if I subtract the exponents kind of upside down. So first of all, I'm going to be left with a negative 5 over 4. See the a to the 8th and the a to the 12th? There's 4 more a's downstairs. Yes, you know, 8 minus 12 would equal a negative 4. I'm going to immediately put it downstairs and write it as a to the positive 4. This 7 minus 8 would be a -1, so I'd have b to the -1 upstairs. I'm going to write it downstairs as b to the first. You do not need to write that 1. This is c to the second over c to the first. When I subtract those two exponents, 2 minus 1, I get 1, so I get to leave the c to the first upstairs. So again, you can go right to that answer right away. Let's go ahead now and do the second objective, which is to divide a polynomial by a monomial. So now I'm going to take this binomial right here and divide it by just x. And before I do that, I want to take you off to the side here and remind you of something, arithmetic with fractions. If I have 2/7 and I want to add 4/7 to that, because they have a common denominator, I just add their numerators. 2 plus 4 is 6 over that common denominator of 7. I'm going to treat these problems right here. They're the same kind of thing. It's 5x squared minus 7x divided by x. So I'm going to write it out kind of in a vertical format. So see right here the 2 plus 4 over the 1, 7. I'm going to take you back here and put the 2 and the 4 in their own fraction over that common denominator. So this 5x squared, I'm going to put it over its own denominator of x. And the 7x, I'm going to put it over its own denominator of the x. And now I have a monomial divided by a monomial. So I'm going to subtract these exponents. So x to the second, x to the first gives me just x. So my final answer will be the 5 and that x. The x's right here cancel out because they're equal to 1. So you have 7 times 1 right there, which is just 7, and we're all done. So it's up to you in terms of how much you want to write down, but I always, in order to make sure I don't make any mistakes, I take this first term and I put the 2y right underneath it. I take the second term, the 4y squared, and I put the 2y right underneath it. And then I go about the process of reducing. Again, remember this is 12 divided by 2. That's equal to 6. Y to the third divided by y to the first is y to the second, because I'm subtracting those exponents. 4 divided by 2 is 2. And y to the second divided by y to the first is just y. All done with that one. Let's go here for the next one. So I've got a -14, p to the third power, q to the fifth power, and I'm going to put the denominator of a -7 right underneath that. Try to line up the p's and the q's. Then the 49, p squared, q squared, and I'm going to put that -7 right underneath it as well. And now I'm going to go ahead and reduce. So this negative divided by a negative, those are just arithmetic. 14 divided by 7 is 2. Negative divided by a negative is a +2. P to the third divided by p to the second is p to the first. I'm not going to put the 1 up here. It's not necessary. Q to the fifth divided by q to the second is q to the third, because 5 minus 2 is 3. Here, this is an addition sign, but I have this +49 divided by a -7 is a -7. You can write this as plus a -7 or just -7. And oh, this is interesting. P squared over p squared is equal to number 1. Q squared over q squared is equal to the number 1. So I just had this -7 times 1 times 1. So I just leave this as a -7, and I'm all done. I'm going to stop right here because the next piece is going to take a polynomial divided by a polynomial.